Okay, some of you were gone when we talked about how to graph multifunction equation, or better known as a piecewise function. What a piecewise function is that you are going to piece together different parts of the function. And the key thing about it is that they are giving you particular domains in which they want you to graph a particular equation. So we actually have 3 domains set up for this one. The first domain that we have would be that x is less than 0. So what we're doing is, I didn't do that right there. Sorry about that. That's what I thought would happen. I gotta move this thing. I'm trying to figure out something here. There we go. Okay, so what we have is we want to be able to graph that first equation is going to fit in the domain where x is less than 0. So everything back over here in this range involves which equation? Negative x plus 1. And we know something about that graph already. What do you know about that graph? What's it look like? It's a straight line that has a y-intercept of 1 and has a negative 1 slope. So if I wanted to graph that, just that particular part, well, I'll come back to that in just a minute. If we look at the second one, the second equation, what's the domain for that particular equation? It's between where? The 0 and 3, because domain means your input or your x values. So my domain is between 0 and 3, which is right here. So anything in this green x range, known as the domain, I am going to graph negative x squared plus 3x. Then we have our third domain, which is when x is greater than 3, and that is going to end up being the graph of everything over here, wherever x is greater than 3. Now I want, you will get, I'm going to give you, 15 seconds with a partner to discuss what's going to make it different, or what is the difference in your graph if you have an equal sign or if you just have a greater than. So you have 15 seconds. What are you going to do, Sarah? Yep. Discuss the difference between an equal or just a greater than. 15 seconds. Go. Okay. Hey, what did you come up with?
That if it's like equal to, it's going to include probably your closed circles on the line graphs, and then if it doesn't, it'll be your open circle. And then for your different functions, I said that only one could be closed if they overlap. So like
Not necessarily. But if it is going to be a function, only one of them should be closed and the other one should be open at a particular x value. Sometimes they might both be closed, or there might be an overlap somehow. But if it does, then it is no longer a function, is what the issue is with that. But for it to be a function, yeah, you should only have one y value for every x value, if it is a function. Now, what we're going to find out is you might have to pick up your pen in order to graph it. That means it's going to be a discontinuous function. A continuous function means you can just put your pencil and you can just trace the whole graph without having to pick up your pencil and jump over to a different spot. That's the difference between continuous and discontinuous. But what we want to look at here is we just want to graph this particular function that's going to have 3 parts. It has the part in yellow, the part in green, and the part in blue. And we came up with those three regions based off of what the actual domain is, which is stated in x is less than 0, if x is greater than or equal to 0 and less than or equal to 3, or if x is greater than 3. So we look at the very first one. In this yellow region, I want to graph this line. Now you've been graphing, so we know that in order to graph information in this region, I could just pick values for x and figure out what the y or f of x values are. If you pick values, you always want to include the values that are within the domain, but keep in mind they're either going to be open or closed circles. If I graph just this graph, you've already told me that it is a graph where the y-intercept is 1 and it has a slope of -1. So your graph would look something like, if you were to graph it, that's the graph of the line, the very first equation. But what do I want? I don't want anything over here in the green or the blue. That's going to change your graph. So what I want is I just want what's in the yellow region, that particular domain. So that's going to take your graph and it's going to shorten it up. Whoa, don't know how that happened. We'll undo that though. And I got some box here. I don't know how I got that. I still have that. So okay, I don't want this here. I don't know how to get it. There we go. All right, so what we want is you can pick the values. We could say we have the values 0. That's within the domain. And it's the values less than that, so we're going to pick -1, -2, and -3. And if you put 0 into the equation, what do you get? I want to put it into a -x plus 1 equation. So if I put 0 in, you're going to get 1. If you put -1 in, you get 2, because it's the opposite of -1, which is 1 plus 1, which is 2. If you put -2 in, the opposite of -2 is 2, plus 1 is 3. And if you put -3 in, you get 4. Now, those happen to be at 0. We get, let me erase this for a second. At 0, we get 1. So you have to go back up to your domain and you say, does it include that? No, it doesn't say equal. If it does not say equal, then that means that this value is going to be an open circle. Now you have to have that as an open circle, and you just don't start picking your points at -1. Because if you just started your points at -1, at -1 I get 2, at -2 I get 3, and at -3 I get 4. If I were to just graph that, is that including everything in my yellow region for the domain? No, I still have this region right in here that I got to fill in, because -1/2 still fits the qualifications or the domain for that very first equation. So that's why we go back and we make it an open circle, as if right at 0 I would have that value, but it does not include that. And then this pattern continues in that direction. So there's your first graph. Now you have to graph enough so that you can see what your graph is going to look like. Well, that's a straight line. We know that. We have enough in the yellow region, but we need something with the green and the blue domain. So what happens? We go to the green. And the green says is that when I pick values, what particular values do I want to pick? Ones between 0 and 3. Now I want to include that 0 and the 3. So I'm going to pick 0, 1, 2, and 3. Now at 0, does it say in your equation or in your domain that it includes 0? Yes, so that means that it's going to be a closed circle because I want to include it. 3, is that going to be an open or a closed circle? A closed circle. So now when I pick these, when I get those points, those x values, what equation do I want to put them into to figure out what the output or the range is? You put it into the green equation, which is -x² plus 3x. So if I put 0 in, what do you get? 0. That's a nice one to do. If you put 1 in, 1 squared is 1, then it becomes -1 plus 3, which is 2. If I put 2 in, you're going to get -4 plus 6, which is 2. If I put 3 in, you're going to get -9 plus 9, which is 0. So I plot those points. I have a closed circle, 0, 0. I have the point 1, 2. So at 1, I get 2. Can you see that green point there? Then I go to the next point, which is 2, 2, which is right here. And then I have the point 3, 0, which is right there. We have those points. Let me go back and just make them dots. I'm just going to try to distinguish them somehow. I'd like to use the green, but we'll do the black. There's a point. At 1, you get 2. At 2, you get 2. And at 3, you get 0. Now, do you think your graph's going to do this? No. Because this is the graph of what? A parabola. And a parabola curves. It rounds. So we need to figure out where is this peak at right here. It has symmetry, so it's got to be halfway between them. So what we're going to do is we're going to come back over here, and we're going to insert 2.5. Okay, get your calculators, and I'll give you a second to type 2.5 in. You take 2.5 squared. You could actually use 3 halves if you prefer to use the, not 2.5. What do I want? I don't want 2.5. What do I want? I want 1.5. It's halfway between 1 and 2. You want 1.5 or 3 halves. So take 1.5 and square it. You have to negate it. And then add 3 times 1.5. 2.25. Is everybody getting 2.25? Okay, so now what I can do is I come back over here to my graph. Hopefully I'm not going to erase my highlighting. I erased it a little bit, so we'll just go back and fill that back in real quick. So what I find out now is that if I go to graph that, I'm going to plot my points. Go back to 0, 0. That's a closed circle. At 1, you get 2. At 2, you get 2. And at 3, I get 0. But at 2.5, I get 1.25 or 2.25. Now, does this take on the characteristics of what I know is the graph of this green highlighted function? Yeah, it's a parabola. The negative in front of x squared says it opens downward. I have that. But I have a specific domain that it needs to fit in between. It has to fit between 0 and 3. And it does. That's the green region. Now, the blue domain that was given to us is x is greater than 3 is going to be the graph of what? A line. So we look at graphing that. If I want to graph that, I am going to, and some of you could just graph it because you know enough about lines and how you can graph a line. So I look at it, and we know that we want to pick the values of 3, 4, 5, and 6. Now notice each one of your tables picking those values has something within this domain. I have 0 and values less. I have 0 to 3. I have 3 and values greater. So you put 3 into the equation. If you put 3 into which equation again? The blue, which is the x minus 2. If you put 3 in, you get what? 1. If you put 4 in, you get 2. If you put 5 in, you get 3. And 6 gives you 4. So I'm going to plot those points. If I look at that 3, go back to your domain in the highlighted equation. Is that open or closed circle, and why? Open because it does not equal it. So this is an open circle. So I go and I plot that point. So when x is 3, y is 1, and that's an open circle. I go to the next point. At 4, I get 2. At 5, I get 3. At 6, I get 4. It's the graph of a line that has a positive 1 slope and rises up to the right. Now, if I were to continue that, in this direction, does it have that y-intercept of -2 that we talked about when we Yeah, it does. But we don't want that in our graph. I got that extra little. So this is the piecewise function, the whole thing here. This graph has got this upside down curve with two V's coming off of it, or two not V's, but arms coming off of it. When you look at that, that's the graph of this particular function. It's a piecewise. You have to look at individual domains and then graph it. That's what you are going to be doing in problems 27 through 32. Yes. You look here at this domain. Can you read that for me? So if x is less than 0, here's my origin. This is less than 0. What's this say? Read it as x. X is what? Greater than or equal to 0 and less than or equal to 3. It's between 0 and 3. Is that what I have right here? And this says x is what? Greater than 3. 1, here's 1, 2, 3. It's anything greater than that. So it all comes from this right here. Question? All right.